The following is a quick walkthrough on how to do RFM analysis in Python. RFM analysis or recency frequency monetary analysis is one of the most important and crucial customer segmentation analytics technique followed by marketing teams all around the world. The idea behind this analysis is to group our customers or clusterize the customers based on three quantitative parameters. These three parameters are recency, frequency, and monetary. Recency stands for understanding when was the last time customer bought a product or service with us. Frequency stands for understanding the number of times customer interacted with our business within the data time frame. And the monetary value stands for understanding what is the total amount of money customers brought for our business. Using these three parameters, we are gonna group the customers in a number of clusters, and we are gonna see in which cluster majority of our customers fall in. So as we can understand our customer base, not only that, we could focus our advertising and marketing strategies in the group or in the cluster group in which is much needed. So let's get started. Right, so as you could see, I've already imported some basic packages we need to do the initial first phase of the analysis. All right, but I haven't imported the machine learning models yet. So we'll do that down the line when we come to that point. So let's run this again and let me import the data set. CSV. So I have the data here. So this is the data which you're using. Since I know the name, I'm just typing it. All right. Oh yeah. So we're gonna change this. Sweet. Now we have the data in the system. Now if you run the head 45. Right, so basically what we have here is a sales data. We have the bill number, we have the item name, we have the quantity of item purchased, the date, the price, the customer ID. All right, and from, I think this has a list of countries as well. Let's just see what all countries we have here. All right, I'm just gonna do a value count. All right, so we have a lot of different countries here, but majority of the data is from United Kingdom. So if you want to scrutinize the data and do the RFM analysis on a particular country, you can do that. But in this video, I'm going to stick to the entire data set here. All right, so now what we can do is just close it. Let's understand the D types. All right, so bill number is good, item name. Date should be converted to date time, and price should be converted to float for analysis because we'll use those two values as well. And if you could see, the price is separated by a comma instead of a period, so we got to change that as well. So let's just do those first. Okay, copy this. Alright, so that should be it. Now let me just see the price is now changed to float data type, and let's run the tail here so that we can see. Alright, so now the period, comma is gone and the period is on. So that should be it. Now we can change the date to the datetime object when we find out recency. That's where we're going to use it. We'll do that in that process itself. So that's where we are heading right now. So we're going to understand the next step we are going to do right now is that finding out each customer's recency, frequency, and monetary value from values. All right, so first let's start with recency. So when it comes to recency, it's all about understanding when was the last time customer interacted with us. All right, in order for Python to do that, we need to give Python a present date, and the Python is going to find out the last time customer brought a product with us since the present date. All right, from the present date, it's going to calculate how many days since the customer has brought product with us from the present date you give here. So if you could check the data set here, we have the last data point here to be at December 9th of 2011. All right, so you can give this date as your present date or the days after that or whatever, but I'm gonna consider a thing that I'm doing this analysis on the 1st of 2012, the next month from the last data point. So that is where I'm going to do that. So it's equal to PD to date time. Oh no, Alright, so that should be it. Now let's find out the recency. If you go here, run this, we're just gonna group by customer ID, and we're gonna just do some aggregates here. Let's do by running date, run this lambda x day minus x dot max day saves. Yeah, so that should be it. Now if you run this, alright, so now we have the recency value of each customer. So let me just run like 3 of the head, then I'll explain this to you. Alright, so as you could see, what is this data tells us is that, so customer ID 12346 has contacted us 347 days. The last contact he made with us, by contact I mean purchased a product or service with us 347 days before the present date. Alright, it's been 347 days since he brought a product with us. But the second customer ending with 47, it's been 61 days, and the 49th customer, it's 40 days. That's how it is. Alright, so now let's find out the frequency. So I'm gonna just name it freq df.drop duplicate subsets roll number group by, now we are gonna group by the customer ID again, customer ID, bill number, and take the accounts. Alright, so it should be, there's some issue there. Let me just check drop duplicates. Alright, so wait, oh, it's if bill number, actually we gotta change that as well. Oh yeah, and there's a match thing here. So that's it. Now if you run frequency.head.10, sweet. So what this data actually tells us is that customer ID ending with 46 only contacted us one or interacted with us or purchased a product or service with us only once as per the data set we have. Alright, so but the second customer ending with 47 has made a purchase of product or service with us 7 times. That's the frequency. Now the last thing is the monetary value. So when it comes to monetary value, we have to find the total amount of monetary value each customer has brought to our business. Alright, but we don't have the total amount, but we have the quantity and price. Multiplying that will give us a total amount. So that's what I'm going to do here. Alright, so it's going to be price multiplied by, what's that, quantity. Right, so now we have the total. Now it's just grouping and taking out the sum. Alright, so I'm just gonna name this yeah, let's name this money df dot group by customer ID, total. I'm gonna take the sum out of it. Now if you run the money, alright, so now we have the total amount of money each customer has brought us. So the surprising thing, if you could see here, is that the first customer ID had a very less frequency. He has just only contacted once, and it's been 347 days, and he hasn't contacted us after that. But the monetary value he has brought us is huge. He has bought something for very high amount of money. Alright, so that's what it means. So now let me just add all these into a new data frame. Let's say recency, frequency, monetary, access equal to run RFM. Alright, Alright, so now you have the data frame I want, but the column names are not the same. You gotta change all the column names. I'll do that here. Recency. Frequency.columns. Frequency. Okay, now money.columns. Monetary. Alright, so sweet. That should alright, so now it's changed. So now we have each customer's recency, frequency, and monetary value. That brings us to the end of almost the 50% of the project. Now we have to import two machine learning tools here, machine learning model algorithm tools here, so that we can clusterize this data into multiple, group the customers into multiple clusters based on the data set we have. All right, so in order to do that, before we understand or find out the number of clusters we have and group the customers into it, we have to standardize the data. All right, so because this data frame we have has different scales based on the column, or recency has a different scale, monetary value has a different scale, but the machine learning model, to be efficient, we need to have a common scale. So that is where we are going to sought the help of something called the standard scaler or z-score normalization, that's used to convert the entire data frame into a common scale for all the values in the columns, for all the columns basically, so that it could help the machine learning model to be more efficient, right? So let's import from sklearn.preprocessing import standard scaler. Right, I'm gonna store this into standard scaler. Now let me just bring in our data frame so that it can fit to it. RFM. So that's it. That's the first step. That's done. Now we could understand. Now we should not. Now all you have to do is that understand the number of clusters we have. Then we have to group the customers based on the clusters where they belong to. All right. So in order to do that, I'm gonna bring in another package called cluster import k-means. K-means is a unsupervised machine learning algorithm used for clustering data points based on similarities. Alright, so that's what we are going to bring here, and I'm gonna run it through the entire data frame so that we can understand. Try in np.range 1,11. We're gonna run k-means is equal to k-means dot. Oh, it's basically in clusters. I'm gonna enter I, because the process we are doing here is that we are just trying to understand what is the number of clusters which we have in this entire data set. All right, so that's why I'm mentioning I here. So I'm creating a function which runs through this entire data set, which will find out the number of similar clusters, and it will give us a result, and the result is for us to interpret from a graph. All right, so when we run through this whole program, which I'm yet to finish typing it will give us a graph in the form of a line chart, and from that we have to interpret the number of clusters we have. All right, so I'll explain it better when we get to that point. Let me just now it's all about k-means dot fit the scale data within it. Now let me just inertia outpoint. What is that? K-means inertia. Alright, so that's it. Now let me just plot that show inertia marker. Marker is equal to its plot. Right, so as you could see here, so this is a line graph I told you about, and this whole method is called elbow method. The reason I didn't tell you the method, the name of the method first is that because I just want to show you the graph, then I want to explain what is it all about. All right, so we wrote this whole thing to understand the number of clusters. All right, and it is for us to interpret the number of clusters we have. So the model will help us to do that with the help of this graph. This graph is called the elbow method because this whole line represents an it is similar to our hand from the tip of the shoulders to our fingertip here. All right, so by elbow method what it actually means is that we have to find out the particular point which almost represents the elbow. All right, so if you could check in this data, this particular point represents the elbow, so which serves us, and that it represents an elbow, and that particular value which falls on that point where it represents the elbow is a number of clusters we have. For example, this elbow falls in between 2 and 4. All right, right in the middle of it, and it is 3. So basically the number of clusters we have in this entire data set is 3. That's what it means. All right, so this is how you find out the number of clusters we have using this k-means unsupervised machine learning algorithm model, and it is one of the most widely used way to find this number of find the number of clusters we have. It's called the elbow method, finding out the particular point we have as the or corresponds to an elbow joint. All right, and the value it falls on is a number of clusters. Okay, so now I'm gonna just copy this. We're gonna make some small change here. Instead of running number of clusters is called I'm just gonna enter 3 because we obviously know the number of clusters is 3, and now we have to label. Oops. Let's take this out. We don't need this, but what we can do is that we can just create something called clusters, and we can run this inside. Now we are gonna leave. Alright, so now if you run this and open the data frame, now you'll have a dedicated column which will say on which cluster group each customer already belongs. Right, so other thing you should notice here is that we obviously know we have 3 clusters. All right, but you could see the cluster indexes are 0, 1, 2. It is because the Python environment takes the first cluster as 0, the second one as 1, and the third one as 2. Right, so if you want the cluster ID to be named as 1, 2, 3, then you gotta come here, just enter +1, which will change everything. Now we have a cluster ID 1 for the cluster 1, 2 for 2, and 3 for 3. All right, so this will give us an idea on which cluster each customer groups belongs. Now let's let's dive a little more deeper on the clusters we have got here and understand its mean, so that we could see what is the mean recency frequency monetary value of each cluster. All right, so let's do something called group RFM group by. So I'm gonna do clusters, then I'm gonna group by recency frequency and monetary, and we're gonna take the mean. So mean will give us enough information we need. All right, so as you could see, this is one of the most important data. It's basically the result. All right, so one of the results, let's say. So if you could see, cluster 1 has a recency of 68, all right, on average, frequency of 4 on an average, the monetary value of 1000, almost 2000, let's say. All right, so this is how the cluster 1 is performing. The customers, on an average, the customers who belongs to cluster 1, they produce these results. All right, if you check the cluster 2, their recency is much better than their cluster 1, and their frequency is huge as well. They've been contacting us very often, and the monetary value they bring is very huge. All right, and if you check the cluster 3, their recency is very bad, frequency is very low, and the monetary value is very poor. So if you're going to name these clusters, I'm going to name the first one as the average clusters, or the average customers. The second one are the whales. They bring a lot of money to us, and their frequency is huge as well. The third one are the lapsed customers, or the customers who are not loyal to us anymore. All right, so we have a exclusive column which says the clusters here, but we don't know in which cluster group he belongs, which means whether he's average customers, lapsed, or whale. All right, so let's do that by creating a function called row. Now if row clusters equal to 1, so as per this analysis, 1 should be average CX. If row clusters, if it is true, right now we have the whales in 2, and then we have else return lapsed CX. Right, so that's the function. Now let's run it on the data set we have by creating a new column. Let's say something called condition from dot apply function. All right, let me just see that quickly. Clusters. Oh yeah, let me just do the axis as well. Let's see whether that will work. Sweet. All right, so now if you run RFM, bingo. So we have each customer ID and the condition, whether he's a whale or something. All right. So if you could see, the customer ID 1 has a very poor recency, but the monetary value he brings us is very huge. Whenever he comes, he brings us a monetary value. All right. When customers spend a lot of monetary value, it shows us they are like obviously interested in it. So he comes under whales, the next 2 followed by our average. The last 50, customer ID ending with 50 has a recency of 332, which is very low. He has only connected as 1, and the monetary value is less as well. So let's understand the spread of these customers here. I'm just gonna do a small pandas plot so that show us which customer is huge. Basically, I'm running value counts and a plot. Alright, so now if you run result. Alright, so in this entire database, based on this machine learning k-means clustering, we have cluster customer into 3 groups: average customer, lapsed, and whales. Huge number of customers fall under the average CX. Alright, followed by we have lots of lapsed customers who are like one-time purchases, but then their monetary values are low as well, and they don't come again very often. So let's say that. But the whales are very few, but they bring us monetary values. All right, so if you could ask me, the dedicated customer, the very loyal customers we have in this entire data set is very low in this company, but we have a lot of average customers which we can obviously turn them into more loyal. So that is what I meant by RFM will help us to create advertising and marketing strategies. Now we know which customer group to focus to so that we can target on them and bring them or make them more loyal to our business. All right, so I'll just do a small pandas plot with the same let's say colors, red, green. So as you can see, the whales are very few, but they bring us a lot monetary value. Average CX are huge. There's always a room for improvement with average CX. We can create marketing advertising strategy focusing on these customer IDs who fall under average CX to convert them into more loyal. And we have the lapsed customers. So right now we know who all the customers are lapsed. We can figure out advertising and marketing strategies to convert them as well. So that's it. So this is the way you can do RFM analysis, and it will help us to segment customers based on these parameters RFM. Right, so I'll post the code in my GitHub, and I'll post a link to the GitHub in my YouTube description. You can check that out as well. So see you all in the next.